Hey kids, this is lesson 15 and guess what? It's all word problems. I know it's everybody's favorite thing is to do word problems. Sarcasm. You can do this. We are going to break these things up. We're going to use tape diagrams. We're going to use the strategies that we've been working on. I don't have special notes, so we're going to dive right in. Number 1, in a race, the second place finisher crossed the finish line 1 1/3 minutes after the winner. The third place finisher was 1 3/4 minutes behind the second place finisher. The third place finisher took 34 2/3 minutes. How long did the winner take? So when you have a race, sometimes I'll put like literally the finish line. Okay, and so this is going to be first place. And then you've got the second place finisher who is behind, and then you've got the third place finisher who is behind that person. And we don't have this time. So when you take this type of a race, you can make tape diagrams that literally extend so that we have the fractional units that we can put in there. So the first place finisher is unknown time, but we do know that after that person, this section is 1 1/3 minutes after the winner, so plus 1 1/3. The third place winner was 1 3/4 after that one. Okay, and so if you wanted to put your X marks the spot, this would be plus 1 1/3, and this is the plus 1 3/4. So it just depends on how you see it. Remember, the strategy, read, draw, write, is to draw whatever will help you make sense of these problems before we write it all out and try to solve. Okay, so if you wanted to set it up with a number sentence, we do know that 34 and 2/3 minutes, okay? And then we have to combine, or this is the slowest person, so we're going to take off the second place 1 1/3, and then we're going to take off that 1 3/4. But we need to combine these times here in order to figure out how much time is added to or subtracted from this to get that first place winner. Okay, so let's do it. We need to have common denominators here because I can't add thirds and fourths. So let's take our 12ths. And okay, now this is, again, this is how we set it up, but this whole thing together is going to come off. So I'm going to combine these two times, and I need 12ths. And so 3 times 4 is 12, so 4 times 1 is 4. And 4 times 3 is 12, and 3 times 3 is 9. So you should end up with 1 4/12 plus 1 9/12, and then we're going to combine these, and we get 2 and 13/12. And this in itself is 1 and 1/12. So you add that to the 2, and you get 3 and 1/12. So the first place winner came in, and then 3 and 1/12 minutes later, the last person came in. So now we have something we can work with. The third place, or last in our problem, is 34 and 2/3. And we know that this is the time that that last person got, but what we need to do is take all this time away because a winner is faster, so we need to have a lower time. Sometimes that'll throw off kids. What do I do? Do I add or do I subtract? So for this, because we had to combine all the time after the winner, we had to add. But now now that we know the total, we have to take that off. And I need 12ths. 3 is a factor of 12, so I'm going to just change this fraction and make 12ths here before I do my subtraction. So I'm not using this other number. I'm not cross multiplying. I'm using a scale factor. If you want to write that over here, 2/3 times what fraction will give me 12ths. You can always set that up so that you can see the change happening, or you could set it up with parentheses like we did previously. But the scale factor is 4. And that gives you 8/12. And so we have 34 and 8/12 minus 3 and 1/12. So do the whole number subtraction. And because we can do the subtraction here, we're going to go ahead and take that right away. And so this is the winning time. How long did the winner take? 31 and 7/12 minutes. But you also sometimes need to know time as far as how to create a clock time. Like nobody's going to say, oh, well, I won in 31 and 7/12 minutes. Well, how many seconds is that? So on these types of questions, I want you guys to be watching out for how many parts are in the whole, okay? A clock has 60 minutes, but 60 is a multiple of 12. So 12 times what equals 60? If I want to get to here, and another way of looking at it is 60 divided by 12 is what? So if you want to set it up long division because you don't know, but it really just comes down to, hey, this is a single digit factor here, okay? And so it's going to be, there are 12 5-minute increments in 60 minutes. And so then you get your 35, and this means minutes out of 60 minutes. So really the answer comes down to 31 minutes, or actually this is seconds. Whoopsie. There it is. First mistake of the day. But it also would apply, but except they're not asking us about that. So it's 31 minutes and 35 seconds. Okay, so this is adequate, but there will be questions somewhere, maybe on a state test, maybe on an assessment, and it will say, hey, use this minute fraction and turn it into actual seconds. And so that's pretty common. Let's move on. Okay, John used 1 3/4 kilograms of salt to melt the ice on his sidewalk. We were just talking about that, how the salt can change the temperature of the water and not let it freeze. He then used another 3 4/5 kilogram on the driveway. If he originally bought 10 kilograms of salt, how much salt does he have left? This is a classic tape diagram. Classic 10 kilograms altogether. He's got sidewalk, driveway, and left. And we have the amounts here that are given to us. So we have 3 parts. We have 1 3/4, 3 4/5, and mystery. I don't know. This is for the sidewalk. And this is the driveway. We'll just abbreviate. So when you look at a tape diagram, the idea is I should see the parts that make up the whole. And I believe it's the next lesson, but we're going to be getting into that pretty soon, learning how to make these tape diagrams and make sure they're really accurate. So initially, if you wanted to set this up as an expression, I could take off the stuff that was used, the salt that was used there, and I could take off this salt that was used here. But again, I'm taking away all this. So instead of doing multiple subtraction problems, which you can do and you are more than welcome to do that, I always prefer taking everything that's going to be subtracted and I just add it all together. and we need to have a common denominator. And you can start with the whole numbers by combining and then just go to your common denominators. Okay, so whole numbers, and then now we can just focus on this. 5 is my scale factor here, so 15 is on top. 4 is my scale factor for this one, so 4 times 4 is 16. And then when you add this, you get 31. And this in itself is a problem that needs to be solved. And so 1 and 11/20 that you would combine with the whole number. And so 5 and 11/20 is our total. So now what do? So if this is the total that is already dumped on the sidewalk and the driveway, this is why it's really important to label these things, because you want to keep track of what you're solving for, because that's not the end. Like, you can't just circle this and walk away. We just figured out what this total is, but the question is how much is left. So you want to take this away from 10. And right here we have one of those subtraction problems that, because I only have a whole, I can go 10 minus 5 is 5, then continue down the number line in a negative direction. So what's 5 minus 11/20? Remember, go down one digit and then make up the difference between 11 and 20. And this is what's left. There you go. Sorry, it's like smushed off the page. So hopefully you can see that pretty clearly. Okay? Yay. It's always so quiet here. Okay, oh, love the names. This is always fun. Sinister Stan stole 3 3/4 ounce of slime from Messy Molly. It's like the writers were getting really punchy at this point. It must have been a Friday. But his evil plans require 6 3/8 ounces of slime. He stole another 2 3/5 ounces of slime from Rude Ralph. How much more slime does Sinister Stan need for his evil plan? Try to read this 5 times fast without getting this tongue twister all messed up. All right, another place for a great tape diagram. His plans require this amount. This is a fancy way of saying, I need this. I need that to be the total. Okay, so the total always goes on top. 6 3/8 ounces of slime is what's needed. Now we have Messy Molly and Rude Ralph, but he also needs more. So again, classic. Let's just say MM and RR. He stole 3 3/4 ounces here, and he stole another 2 3/5 ounces here. And this is the need. And I don't know. So we'll have to figure that out. But what you can see is that these 3 parts make up the whole. So let's combine what we know we have so that we can take it away from here and figure out what the difference is. 3 3/4 plus 2 3/5. Can't do it without a common denominator. You can combine the whole numbers and then set it up with your common denominators. For 4 and 5, we know that 20 is our common denominator. For 4, 5/5 is the scale factor for this one. So 5 times 3 is 15. For 3/5, 4/4 is the scale factor for this fraction, and 4 times 3 is 12. When you use the other number on the denominator as your scale factor. You don't have to write anything else, just think it in your head and then write it. And then 15 plus 12 is 27. This in itself needs to be solved. And that will give you 6 7/20 ounces that were stolen. I think he's rude. I think Sinister Stan is rude. And now we're going to look at this 6 3/8. This is the total that's needed, okay? Now, it's pretty close, isn't it? He needs 3/8. It's almost half. Almost half. 6 7/20 is stolen. 7 is about 1/3. So I'm going to have a very small amount here. And we have to find the difference. Now, common denominators. If I were a 5th grader, I would line them up and start skip counting. If you know your facts, you're going to recognize right away that 40 is the next multiple of 20. And how many times do you have to multiply 8 to get 40? 5 times. So my scale factor just for this one is 5. My scale factor for this one is 2. Okay? So change away. I need to get from 8 to 40. That's times 5. So 5 times 3 is 15. I need to change from 20 to 40. That's a scale factor of 2. So 7 times 2 is 14. Here is our subtraction problem. We knew it would be close because we compared fractions before we started. And 6 minus 6 is 0, and 15 minus 14 is 1. And so 1/40 ounce of slime is still needed. And I'm sure he's going to go thieving and take that from some other nice, unsuspecting person. All right. Gavin. Hello, Gavin. Gavin had 20 minutes to do a 20 minutes for a 3-minute quiz. Wow. 20 minutes to do a 3-problem quiz. He spent 9 3/4 minutes on problem 1. Oh, we talk about like managing your time all the time. It's such an important strategy. And 3 4/5 minutes on problem 2. How much time did he have left for problem 3? Problem 1, problem 2, problem 3. And again, classic tape diagram. Problem 1, problem 2, problem 3. We have 20 minutes as our total time allowed. He spent a lot of time on problem 1, though. So he might start to panic. Ugh, how much time do I have left? 3 4/5 minutes on problem 2. And so we need to combine these two and then take that total away from the 20. They don't have common denominators, so let's set it up. Okay, combine the whole numbers to begin. Put your 20 and your 20. Okay, and again, we just keep doing the same thing over and over. It's just like above. If 4 and 5 are your denominators, 20 is the common one. It's the lowest. Use 5 as your scale factor, 5/5. So I would get 15 here. And then use 4 as your scale factor, and you get 16. It's just so similar to the ones that we've already done. When you add these, 31, 12, and 31/20, this is a problem unto itself. 1 and 11/20. We literally just did this on the previous page. It's right here. So if you've already done work, don't be afraid to just look back and double check yourself. All right, now what did we find the answer to? We found the answer to how many minutes Gavin has already spent working on problems 1 and 2. He still has problem 3, and it looks like he's going to have some time left, but we have to figure it out. 20 minutes is all the time he has to work with. Take away the time that was spent already. Now when you do 20 minus 13 and you end up with 7 as your whole number, you still have to take away 11/20. Okay, that's continuing in a negative direction still, which means we don't end up at 7, we go further lower, make up the difference between 11 and 20 with 9, and that's how you end up with your minutes left for problem 3. And again, if they say, oh, write your answer in minutes and seconds, there it is, then you have to convert. Now, how many times can we fit 20 into 60? So what would be our scale factor? Take your 6 and 9/20. And you can multiply by 3 and get your 27 out of 60. And it works for minutes and seconds, but we already have minutes. So it would be 6 minutes and 27 seconds left. And it's so smashed, but that's okay because we figured it out. Hooray! And these word problems are super challenging. Okay, so hopefully that's all clear. Again, try to get to 60 when you're talking about time, especially when they say change it to minutes and seconds. Okay, last one. Matt wants to shave 2.5 minutes off his 5K race time. Very lofty goal there. Good job, Matt. After a month of hard training, he managed to lower his overall time from this to this, 21 1/5 minutes to 19 1/4 minutes. By how many more minutes does Matt need to lower his race time? So let's find out what he has already taken off. Okay, so let's start with our 21 1/5 and take away or find the difference between, so find the difference between 21 1/5 and 19 1/4. And how many times are they going to give us 5 and 4 as denominators? Like, this is not even exciting anymore. So got to have 20ths. Notice I'm going to make this a little bit bigger. 2 and 20ths minus the other 20ths. 5 and 4 are the scale factors for each other. 4 is the scale factor here, 4. And then 5 is the scale factor here. So you end up with the 5 taken away from 4, which you can't do, but we still have plenty to use. So I can change this to a 1 and add to my numerator. If I change the 1 that's in my head to 20/20, then I just add that to the 4/20 I have, and I end up with 24/20. Okay, now I can find the difference. And I see that I have 1 and 19/20 that has been taken off already. Okay. Then the goal, okay, is to shave 2.5 minutes. Okay, so he's taken off some, but this is the goal. So now I need to find the difference between those two. Now 20 is a multiple of 2. So I don't need to change this. I really don't want to multiply 2 times 20 and have 40ths and then have to multiply this by 2. What a drag. So I only want to change one fraction if I have to change it. So 2 times 10 would be 20, so I end up with 2 and 10/20ths. That's equivalent to a half. And then I don't have to change this one at all. But I have that same weird subtraction problem where I have 10 minus 19. And I can't do that, but it's okay because this is that fun thing where you get to take 1 away from here and combine it to make an improper fraction that's awesome. So I'm going to take my 1 and make it 20/20ths, and I'm going to combine it with what I have here for 30/20ths, because 1 and 30/20ths is the same value as 2 and 10/20ths. Yes, it is. In fact, I could show you if we made an improper fraction. 2 times 20 is 40, plus 10 is 50, 50/20ths. But 20 times 1 is 20, plus 30 is 50, 50/20ths. It's the same value. Minus 1 and 19/20ths. Now I can do the subtraction. The difference between 30 and 19 is 11. Oh, and 1 minus 1 is 0. So now I don't even have a whole number. And 11/20ths, oops, which you can barely see because I'm getting to the bottom here. 11/20ths minutes is still needed to like improve his time or to drop the time. Okay? Is still needed to lower. That's a very poorly written sentence. It's not a sentence. There's no period. Okay, anyway, I'm labeling it and saying 11/20ths minutes is still needed. And that's the end. Thank goodness. So, word problems, lots of fun, lots of work.